breadboard was wired up accordingly, making sure that all wires are in the correct position. There was not going to be any short across the board at any cost. By the use of a Bunsen burner, cork borer and a heat-proof mat and gloves, a hole was made in 6 boxes, allowing enough room for wires to come out. The code that can be seen here on the screen was uploaded to the Arduino Nano boards. Before uploaded, it was compiled to ensure that there were no errors present. After the code was uploaded, sensors were tested and a reading of -127 was given out in each instance. Temperature sensors were plugged in and a water bath was used to define each individual temperature sensor number, whilst at the same time ensuring that each sensor read the correct reading. The ground had a hole made in it with a piece of rebar, as can be seen, in order to allow sufficient room for the sensor to be put into place. The sensors were put into place in the ground, 3 sensor sets in each location, 1 in slab, 1 in soil and 1 in grass. Earthworms moved the soil back into position, ensuring that there was no air gaps, which would overall affect the results. Ambient air temperature sensors were built with the use of a plastic bowl to prevent incoming solar radiation affecting the results. They were then hoisted up a metre above the ground to prevent the heat rising from the ground also affecting the results. The sensors were left in place over the period of a cold day for 24 hours, and they were also then left in the period of a warmer day for 24 hours. By this process, results were taken. After results were taken, the SD cards were removed from the sensors and plugged into the computer, in which were analysed and the text files were put onto Excel and then sorted appropriately. Tables and graphs were created and Minitab tests occurred, giving a final conclusion for this experiment.